Hi everyone, this is our final video for the solutions to the 2024 HSC Maths Advanced exam. In this video we're going to cover questions 23 through to 31. 23a. A random variable is normally distributed with mean 0 and standard deviation 1. The table gives the probability that this random variable is less than z. The probability values given in the table for different values of z are represented by the shaded area in the diagram. The scores in a university examination with a large number of candidates are normally distributed with mean 58 and standard deviation 15. By calculating a z-score, find the percentage of scores that are between 58 and 70. Okay, so here's our formula. Z is equal to x minus mu divided by sigma. Now we have got a mean of 58, standard deviation of 15, and we want to calculate percentage of scores between 58, which is the mean, and 70. So the z-score for 58 is just 0. But for 70, let's work that out. So 70 take 58 divided by 15, which is... calculator. 70 take 58 divided by 15.8. And we want, so in between 0 and 0.8. So if we look up actually 0.8 and find this whole area here, then we can just subtract 50%. So 0.8, the area is... so we want the percentage of scores is going to be equal to 0.7881 take away 0.5, which is 0.2881. Okay. Explain why the percentage of scores between 46 and 70 is twice your answer to part A. So remember we worked out this area here. And our z-score was 0.8. So let's work out what the z-score is for 46. It's 46 take away 58 all over 15, which is 46 take away 58 divided by 15 is negative 0.8, which kind of makes sense, doesn't it? So it's here. And you can see that these areas are equal, and we've just got to write that up basically. So the percentage of scores between 46 and 58 must equal the percentage of scores between 58 and 70. In other words, they're equal. Therefore, and then just write this percentage of scores between 46 and 70 is twice the percentage of scores between, I'm running out of room, between 58 and 70. In part C, by using the values in the table above, find an approximate minimum score that a candidate would need to be placed in the top 10% of the candidates. So there's some score here, and let's start with some z-score, where 10% will be on this side and 90% will be on this side. And looking at our table, that's approximately 1.3. So we're just going to solve this equation. 1.3 is equal to x take away 58 all over 15. So 1.3 times 15 is 19.5. Add 58 to both sides, we get 77.5. Question 24. Jack intends to deposit $80 into a savings account on the first day of each month for 24 months. The interest rate during this time is 6% per annum compounded monthly. So it's 6% divided by 12, which is 0.5% per month. Part A, calculate how much money Jack will have in his account at the end of the 24 months. Okay, so the amount that's going to be accrued is going to be equal to the first amount, so $80, and it is going to get 24 months of interest. So 1 plus 0.5%, so 1.005 to the power of 24. The next $80 will get 23 months. All the way down to the last one, which will get 1 month of interest. Now I'm going to turn this around so that I can, and I shall factorise that 80 out. I'm going to turn this around, so I'm starting with this last term. So 1.005 plus 1.005 squared plus dot 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 plus 1.005 to the power of 24. And summing that series, we get 80. We've got A, the first term, is 1.005. R is 1.005. N is 24. Take 1. All over 1.005, take away 1. And putting in the calculator, we're going to get 80 times 1.005 times brackets 1.005 to the power of 24, take away 1, close brackets, on 0.005 is $2,044.73. B, a table of future value interest factors could have been used to calculate how much money Jack would have in his account at the end of the 24 months. Part of the table is shown. What is the value of A in the table? Give your answer correct to 3 decimal places. So if we were using the table, then we would look up 0.5% for 24 months and we'd find this amount here and we'd multiply that by 80 because this is for an annuity of $1. So we know the answer, what it's going to amount to, so all we want to do is divide by 80 and that will give us the future value interest factor. So divide this by 80 and we want it to 3 decimal places, so 2044.73 divided by 80 is equal to 25.559. Question 25a. A function f of x is defined as shown, and h is a constant. Part A, find the value of h such that f of x is a probability density function. Now we can see that this is a continuous random variable because we've got inequalities. It's obviously not discrete, which means that the integral between 0 and h of 1 minus x over h dx has to equal 1. So let's integrate. We have got x take x squared on 2h between 0 and h, that's equal to 1. H take away h squared on 2h, take away 0 is equal to 1. That cancels. And we've got h take away h on 2, so h on 2 is equal to 1. Therefore, h must be equal to 2. Part B. By first finding a formula for the cumulative distribution function, sketch its graph. Right, so recall if we're doing a sketch of the cumulative distribution function, it's going to be an increasing curve all the time. It's not going to dip around like this. Okay, let's start in the middle here. To find this part, we're going to do the integral between 0 and x of 1 minus x over, and remember h was 2, dx, which is equal to x take x squared on 4 in between 0 and x. And substituting in, we get x take away x squared on 4. Take away 0. All right, now here's the important thing. Capital F of x is going to have 3 parts to it, just like this bit. And we would want the last one to be equal to 1. So basically it's going to accumulate, get to 1, and then stay there. In the middle here we're going to have x take away x squared on 4, and we're going to start at 0. So this is for x is less than 0. This one is for 0 is less than or equal to x is less than or equal to 2. And this one is for x is greater than 2. So there is our cumulative distribution function. Now in order to sketch this, we're going to need to graph this middle bit here basically. And I'm going to run out of room, so let's do this and I'll go into a new slide. So we've got y is equal to x take x squared on 4, which is equal to 4x take x squared on 4, which is equal to x 4 minus x over 4. And so sketching it, we're basically wanting to sketch this middle part here. So it's going to be at 0 prior to that, and this is concave down parabola. It's going to cut at 0 and 4, but we're going to end this at 2, which happens to be its turning point, and the y-coordinate there is 1, so it'll come up like this, and then just keep going. And so here is our cumulative distribution function. Part C, find the value of the median of the probability density function f of x. Give your answer correct to 3 decimal places. So we have our cumulative distribution function here, and to find the median, we want to know where that is equal to 0.5. Because remember, the median's got half of the values on one side and half on the other. And we just need to solve this equation. Let's multiply everything by 4. 4x take x squared, half of 4 is 2. So x squared take 4x plus 2 is equal to 0. Quadratic formula, x is equal to 4 plus or minus the square root of 16 take 4 times 2, all over 2, which is 4 plus or minus the square root of 8 on 2. Now we are going to get two positive values here. If I put the first one in the calculator, I will get 4 plus square root of 8 all over 2, I get 3.4, and that's not possible because remember this is 2, so we need it less than 2 basically. So going back in and putting in the negative value, delete negative, I end up with 0.586, and that's actually our answer, 0.586. So the median occurs at x is equal to 0.586. Question 26. 25 years ago, Phoenix deposited a single sum of money into a new bank account earning 2.4% interest per annum compounded monthly. So again, R is going to be 2.4% divided by 12, which is 0.2% per month. Present value interest factors for an annuity of $1 for various interest rates are, and numbers of periods n are given in the table. And we're going to want this one, aren't we? Phoenix made the following withdrawals from this account. $2,000 at the end of each month for the first 15 years, starting at the end of the first month. $1,200 at the end of each month for the next 10 years, starting at the end of the 181st month after the account was opened. Calculate the minimum sum that Phoenix could have deposited in order to make these withdrawals. Okay, tricky question, this one. Probably the most important thing to look at when you're doing one of these questions is to look to see whether you've got the present value interest factors or the future value. And present value means this is 25 years ago when Phoenix deposited the money. So let's call that sum of money M. Not that that's going to be terribly important. Now that sum of money has to cover $2,000 at the end of each month for the first 15 years. So 15 times 12 is 180. And then $1,200 at the end of each month for the next 10 years, which is 120 payments. Okay, we'll calculate the minimum sum. So let's think about it like this. From 25 years ago, Phoenix is going to take out $2,000 at the end of each month for 15 years. It's going to go like that. So that's $2,000. And then after 180 months, they are going to take out $1,200. Now, it's really easy to work out what the present value of this $2,000 is. We would just look this up and do 151.036 times 2,000. But this one is problematic because if I do 1,200 times 106.592. That's going to bring it back to here. And that's a problem. So probably the easiest way, arguably the easiest way, is to work this out. So because effectively they're going to get $1,200 for the whole time, right? And so we'll do $1,200 times, it's going to be 300 months. It's this one here, 225.43. And then make this guy 800. Does that make sense? And so this one's going to be 800 times, we want 180, 151.036. And we're just going to add those two together. Let's see what we get. 800 times 151.036 plus 1200 times 225.43, which gives us 391,344.8. 391,344.8. Question 27a. Find the derivative of x squared tan x. So we've got a product rule. U is equal to x squared, v is equal to tan x. Differentiate. We have got u dashed is equal to 2x and v dashed is equal to sec squared x. Right, so the derivative of x squared tan x is equal to u times v dash plus v, that's an n, times u dashed. And we're actually finished here, but let's just tidy it up. Part B. Hence find the integral of x tan x plus 1 all squared dx, which is equal to the integral of x squared tan squared x plus 2x tan x plus 1 dx. All right, now looking at what we found in part A, if the derivative of this is equal to that, then the integral of this must be equal to that. Right, so I'm going to try and match this. That makes sense. Now, let's turn it around. I'm going to write this one in blue so you can see the difference. So the integral of x squared sec squared x plus 2x tan x dx is equal to x squared tan x. All right, we need to match this. We need to make this equal to that. Now, obviously sec squared is wrong, so instead of sec squared, tan squared x plus 1 is equal to sec squared x is one of those Pythagorean identities, so let's substitute that in instead. So instead of sec squared x, we're going to have tan squared x plus 1 plus 2x tan x dx is equal to x squared tan x. So I'm going to expand that out. Integral x squared tan squared x plus x squared plus 2x tan x dx is equal to x squared tan x. So let's keep going. What we want to do is try and match this. So you can see that we've got the x squared tan squared x, and we've got the 2x tan x. So let's put those two together. Now matching this, we need a plus 1, and then I'm going to immediately take that away so that I haven't changed anything in here. And then I've got a plus x squared dx, and we know that that is equal to x squared tan x. All right, so the integral of x squared tan squared x plus 2x tan x plus 1 dx, and then I'm going to add this leftover bit here, which I'm just going to turn it around, so the integral of x squared minus 1 dx must be equal to x squared tan x. Now integrate this part here. So x squared tan squared x plus 2x tan x plus 1 dx plus x cubed on 3 minus x is equal to x squared tan x. Therefore, integral of x squared tan squared x plus 2x tan x plus 1 dx must be equal to x squared tan x plus x minus x cubed on 3 plus c. Question 28. Anna is sitting in a carriage of a Ferris wheel which is revolving. The height a of t in meters above the ground of the top of her carriage is given by that equation. And t is the time in seconds after Anna's carriage first reaches the bottom of its revolution, and c and k are constants. The top of each carriage reaches a greatest height of 39 metres and a smallest height of 3 metres. Part A, find the value of c and k. Okay, the first thing that we know is that a of 0 is going to equal 3, because it says here t is the time in seconds after Anna's carriage first reaches the bottom of its revolution, and the smallest height of each carriage is 3 metres. So at time is equal to 0, the height is 3. And so we can do c take away k cos 0 is going to equal 3. So c minus k is equal to 3, and that's going to give us our first equation. The second thing we know is that in addition to having a smallest height of 3 metres, it has a greatest height, or maximum, of 39 metres. So let's differentiate this equation. So a dashed of t is equal to negative k sine, actually negative sine, so it becomes plus, pi t on 24 times by the derivative of the inside function, which is pi on 24. So k pi on 24 sine pi t on 24. We want to solve this equal to 0 to get these maximums and minimums. All right, so I can cancel all of that out. We're really solving sine, what's an n, pi t on 24 is equal to 0. So solving that equation, we're going to get pi t on 24 is equal to 0, but we actually already know about that one. And the next time that sign is equal to 0 is at pi. And so disregarding this guy and just looking at this one, we've got t is equal to 24. So after 24 seconds, it is at a maximum. So let's substitute that back in. So a of 24 is equal to c take k cos 24 pi on 24. And we know this is going to equal 39. So 39 is equal to c take away k times cos of pi, which is negative 1. So c plus k is equal to 39 is our second equation. Solving those simultaneously, let's do 1 plus 2 gives us 2c is equal to 42, and so c is equal to 21. Substituting it into here, 21 plus k is equal to 39. K is equal to 39, take away 21, which is equal to 18. B, how many seconds does it take for one complete revolution of the Ferris wheel? So we want to work out the period. And the period is 2 pi divided by n, and n is the coefficient of t in here. So it is equal to 2 pi divided by pi over 24, which is 2 pi times 24 on pi. Cancel it out. It is 48 seconds. Part C. Billy is in another carriage. The height b of t in metres above the ground of the top of her carriage is given by this equation. C and K are as found in Part A. During each revolution, there are 2 occasions when Anna's and Billy's carriages are at the same heights. At what 2 heights does this occur? Give your answer correct to 2 decimal places. So we've got B of t is equal to 21 take 18 cos pi on 24 t minus 6. All right, interesting question. I'm going to start by just drawing this out. Now we'll start with this one. We know it had a period of 48, so it's going up in 12s. 24, 36, 48. Has a minimum of 3, and so it starts down here and gets up to its maximum here, and then comes back down again like that. So that's 3, and this one up here is 39. Now this one here is shifted along 6 seconds. So it starts, if you like, here, does the same sort of pattern, gets up to its maximum there, and then starts coming down. And so just joining that up, I don't know, it'll go like that. So you can see there's 2 points here, one in this first quarter and one in the third quarter, where the carriages are going to be at the same height. So really what we want to do is put these 2 equal to each other. So 21 take 18 cos pi on t, pi t on 24 is equal to 21 take 18 cos pi on 24 t minus 6. And really what that all boils down to is equating cos pi t on 24 with cos pi on 24 t minus 6. Now this doesn't work. Pi t on 24 equals pi on 24 t minus 6, because once we've cancelled all of this out, we get t is equal to t minus 6. In other words, 0 is equal to negative 6. So it doesn't work. But do you remember how cos is an even function? So in other words, cos of a negative theta is the same as cos of theta. Cos of negative theta is the same as cos of theta. So in fact what we want to solve is this. Pi t on 24 is equal to pi on 24, and let's take the absolute value of t minus 6. Okay, because of this, it doesn't matter if we get t is equal to negative t, if that makes sense. These still cancel, and so we've got t is equal to the absolute value of t minus 6. If you remember right back to year 11, this could be t is equal to negative brackets t minus 6. So t is equal to negative t plus 6. 2t is equal to 6. Therefore, t is equal to 3 is one of the times when the heights are equal. It's good, but how do we get this other one? Well, the other thing we know about cos is that it's periodic. It repeats every 2 pi. So cos of 2 pi plus theta is the same as cos theta. So we're going to do pi t on 24 is equal to pi on 24. I'm going to take the absolute value again, and then I'm going to add 2 pi to this. All right, I can cancel these pi's out, and I'm going to multiply everything by 24. T is equal to absolute value of t minus 6 plus 48. All right, so t, we want to take the negative of this, negative t plus 6 plus 48. 2t is equal to 54. Therefore, our other time is when t is equal to 27. Now, we haven't quite answered the question because it says at what 2 heights does this occur? So we need to substitute our t is equal to 3 and t is equal to 27 back into one of the equations, either b of t or a of t. And a of t is a bit easier, so a of 3 is equal to 21 take 18 cos 3 pi on 24. Now, I am going to need my calculator in radians, so let's just make sure that that is the case. It's not actually. Mode, nope, shift, setup, radians is 4. Okay, 21 take 18 times cos of 3 times pi, divide 24, brackets, 4 point, what do we want, 2 decimal places? So 4.37 meters. And the other one was at 27 equals 21 take 18 cos 27 pi on 24. And I'm just going to go back and edit that a bit. Delete 27 and 37.63. 37.63 meters. Question 29. Consider the curve y equals ax squared plus bx plus c. A is not equal to 0. At a particular point, the tangent and normal to the curve are given by t of x and n of x, respectively. Curve has a minimum turning point at x is equal to -4. Find the values of a, b, and c. All right, let's start here. If it's got a minimum turning point, the derivative has to be equal to 0 at x is equal to -4. So let's differentiate. Y dashed is equal to 2ax plus b at -4, which is -8a plus b. This whole thing has to equal 0. So there's our first equation. -8a plus b is equal to 0 is number 1. All right. Secondly, if we've got a tangent and normal meeting at a point on the curve, then that point lies on the curve. So if we solve these two simultaneously, we're going to get a point that lies on here. So let's do that. We're going to have 2x plus 3 is equal to -1/2 x minus 2. Let's multiply everything by 2. So 4x plus 6 is equal to -x take 4. 5x is equal to -10. X is equal to -2. So these two meet at x is equal to -2. And furthermore, when they meet, the gradient of the curve is 2. So let's substitute that in and we'll get another equation. So y dashed of -2, which is -4a plus b, that must be equal to 2. So -4a plus b equals 2 is our second equation. All right, let's solve these two simultaneously. So -8a plus b is equal to 0. -4a plus b is equal to 2. And I'm going to subtract the second one from the first one. So -8 take away -4 is -4a. b minus b is 0 is equal to 0 take 2 is -2. Therefore, a is equal to 1/2. And now substituting into that first equation, we'll get b. -8 times 1/2 plus b is equal to 0. b is equal to 4. So we have y is equal to 1/2 x squared plus 4x plus c. We only need to find c. Now remember how I said these two equations met when x is equal to -2? If we substitute the -2 into either one, we're going to get the y coordinate, and that point lies on this curve. So let's do t of -2. That's -4 plus 3 is -1. That means the point -2, -1 lies on the curve. Let's substitute it in here and figure out c. -1 is equal to 1/2 times 4 plus 4 times -2 plus c. And what have we got here? A whole lot of mess. -1 is equal to 1/2 4 is 2. Take away 8 plus c. So therefore, c must be equal to -1 take 2 plus 8, which is 5. And in the interests of space, I'm just going to put the answer there. Question 30. Suppose the geometric series has a limiting sum s. By considering the graph of this or otherwise, find the range of possible values of s. All right, so the sum to infinity is equal to a over 1 minus r. A is x, r is also x. If there's a limiting sum, then the absolute value of x has to be less than 1. By considering this graph, all right, let's have a bit of a sketch of this and see what on earth this has got to do with it. We've got negative 1 minus 1 over x minus 1. Let's draw this in pieces. We'll start with 1 over x minus 1. So that's going to have an asymptote here, because x cannot equal to 1. And we're going to have a y asymptote here, or a horizontal one, at negative 1. And we have got a negative orientation, so it's not going to be here, it's going to be in here and in here. So that's easy to draw down the bottom there. There. And then we need to look at intercepts. So when x is equal to 0, we get negative 1 take 1 on negative 1, which is negative 1 plus 1, it's equal to 0. So that's nice, it's coming through here. Okay. So you're probably asking yourself, well, what on earth does this graph have to do with this function? And they're actually the same thing. Now, you can manipulate this and turn it into that, but it's actually easier to go the other way. So let's start with y is equal to negative 1, take 1 over x minus 1, make a common denominator. So x minus 1, negative 1 lots of x minus 1, take away 1, equals negative x plus 1 minus 1 over x minus 1 is equal to negative x over x minus 1. So it's similar, but we're not quite there. Let's just come up here. I'm just going to rewrite it. Negative x over x minus 1. I'm going to do a sneaky trick. I'm going to take a negative out of that denominator, like this. Watch this. Does that make sense? Expand this out. Plus x minus 1, right? These can cancel, and I have x over, switch this around, 1 minus x. See? They are the same. So we've established that this is the graph of the sum to infinity. And we're going to have a sum to infinity providing the absolute value of x is less than 1. Or in other words, x has to lie between negative 1 and 1. And on our graph, that is about here. Now we want to work out the range of possible values. So we know this is heading off to infinity, but we need to know what the y coordinate is here when x is equal to negative 1. So let's just substitute that in. So y will equal negative 1 over 1 plus 1 is negative 1/2. And so our range is going to be negative 1/2 is going to be less than s is less than infinity. Okay, last question. Question 31. Two circles have the same centre O. The smaller circle has a radius 1 centimetre, while the larger circle has radius 1 plus x centimetres. The circles enclose a region QRST, which is subtended by an angle theta at 0 as shaded. The area of QRST is A centimetres squared. A is a constant and is greater than 0. Let P centimetres be the perimeter of QRST, part A. By finding expressions for the area and perimeter of QRST, show that P of x is equal to 2x plus 2a over x. Okay, so we'll start by writing an expression for the perimeter. So P of x. Now remember that the length of an arc is equal to the radius multiplied by the angle in radians. it doesn't actually say in this question whether the angle is in degrees or radians, so we're just going to assume it's in radians. All right, so we're going to want to go this arc length plus this arc length plus this. All right, so we're going to have the radius for this part here would be x plus 1. So x plus 1 times theta. And going around the shape, we've got plus x plus, and this arc length here would be 1 lots of theta, and then finishing it off plus x. All right, tidying that up, we have got x theta plus x, well, it's actually 2x plus theta, which is equal to x theta plus 2 theta plus 2x. All right, let's have a look at what we've got here. We don't want any thetas, so let's factorize that theta out. And now we are going to work out an expression for the area. Now recall the area of a sector, so all of this is a half times the radius squared theta, and theta again is in radians. So we want to do this whole area, take away this one here. So it's going to be a half. Our radius of the larger sector is x plus 1, all squared theta, take away a half. The radius of the smaller sector is just 1, and then times theta. So we're going to get theta on 2, and we've got x plus 1 all squared, take away 1. Let's just tidy this up a bit. We've got theta on 2. Expanding this out, we've got x squared plus 2x plus 1, it's a 1 there, minus 1, equals theta on 2. That, of course, cancels out, and we're going to have x and then x plus 2. Now we want to make theta the subject of this. So theta is going to be equal to 2a over x plus 2. And I'm going to take this here and substitute it in there, which will give me, it's going to be, instead of theta, 2a over x brackets x plus 2 times x plus 2 plus 2x, which is equal to 2a over x plus 2x as required. B. Show that if the perimeter P of x is minimized, theta must be less than 2. All right, so we're going to start by differentiating. So this is equal to 2x plus 2ax to the negative 1. So P dashed of x is equal to 2 plus, let's bring that negative down, negative 2ax to the negative 2, because remember that a is a constant. Tidying that up is 2, take away 2a on x squared. Now we want to find when we have a minimum, so we're going to put this equal to 0. Let's just tidy that up a bit. We want a single fraction here, x squared on the denominator, 2x squared minus 2a. And so we are wanting to solve 2x squared minus 2a is equal to 0. And so we have 2x squared is equal to 2a. Divide both sides by 2, x squared is equal to a, x is equal to plus or minus root a, but x is positive. Therefore, x is equal to the square root of a. We need to prove that that is a minimum, so we need the second derivative. So that's equal to negative 2 times, bring this down, negative 2ax to the negative 3 is equal to 4a on x cubed. Substituting in square root of a gives us 4a over square root of a cubed, which is greater than 0, which is concave up, therefore a minimum. Okay, so we've established that x equals root a is going to give us a minimum perimeter. But how do we answer this? Now we could go back to the equation for the perimeter, but it doesn't help us because that's variable, whereas area isn't, it's fixed. The area of this is a centimetre squared. So let's substitute our solution in and figure out an equation involving theta and a. So a is equal to theta root a on 2 and then root a plus 2. All right, I want to make theta the subject. So theta will be equal to 2a over root a and then in brackets root a plus 2. And I can tidy this up. That will become root a on top. So what, you're probably saying? Well, here I have got something that I can sketch, and it's actually an hyperbola of sorts. In fact, if I put theta on this y-axis and the square root of a on the x-axis, I could graph this quite easily. And if I can find a horizontal asymptote of 2, then I'll have proved this. Theta must be less than 2. Okay, because I have used x is equal to root a, which minimises the perimeter, to form this equation. To make sense? All right, so let's see, how can we do that? Look, one of the easiest ways that I find is to do this. Theta is equal to, and I'm just going to match this denominator. So I've got root a plus 2. So on top, I want 2 lots of root a plus 2. Now, obviously I can't leave it there because I've changed it. So I'm matching the denominator, right? I've got 2 lots of that. Now, the 2 root a I've already got up here, but I've introduced a plus 4. So I'm going to subtract that 4, all right? Check that out and make sure that makes sense. So now, if I split this fraction up, I have got 2 take away 4 over the square root of a plus 2. Okay, now we can find the horizontal asymptote just by taking the limit as root a tends to infinity of 2 take away 4 over square root of a plus 2, which of course is equal to 2 because 4 divided infinity is 0. Now if we sketch this, just working out the x-intercept, if I put a is equal to 0, I get 2 take away 2 is 0, so it's going to come up through here. Of course, it can't be negative, so it's going to come up through here like this is the graph. So if the perimeter P of x is minimized, then x is equal to root a. And if x is equal to root a, then theta must be less than 2.